This is an introduction to the TILOS software produced by Trimble and sold exclusively in the UK by Elecosoft. TILOS is for linear projects, so time location planning, also known as time chainage or March charts, and it's used for on road projects, rail projects, both long and short, like possessions, tunnels, pipelines, power supply, overhead line and cable, bridges, etc. So anything with a linear component, TILOS is the place to start. It's not just a picture. TILOS is also fully featured project management and control system with resources, costs, and progress management. And at the heart of the idea of time location planning is that you can see an overview of the project and at a glance you can understand a very complex system. So this is a historical but classic example of something that conveys that information. And this is Napoleon's size of Napoleon's army marching into Russia in the early 18th century, and the brown line is the march to Moscow and the black section is the retreat from Moscow, and you can see against distance and the size of the army. So this is conveying complex information at a glance, and that's what time location planning is for. So classically in project planning, you would create a network diagram either directly or indirectly through a linked bar charts. And the network diagram is saying that activity B must follow activity A, but there's no indication of the relative duration of those tasks. And so it's very common, and the most popular way of seeing it, of course, is to set those activities against a timeline. So then on a time scale, you can then see by inspection the relative length and duration of those activities, and you can see that B follows A in both start and end. But when this is a linear project, you've got extra dimension to play with. So you've got a time axis in one dimension and a distance axis in another. And in TILOS, it doesn't matter if the location is vertical or horizontal, and it doesn't matter if the location goes left to right, London to Brighton, or it goes right to left, Brighton to London. It doesn't matter if the time goes down, if the early activities are at the top or the early activities are at the bottom. That's purely a preference, and it's just a switch, a tick box to change the two around. But when you've got the same activities as we saw a minute ago, we've got more information that you can only see and understand and convey and think about the planning process against the distance axis. So when you've got that activity A plotted against time and distance, it gives us extra information. We can see where we're going to be at a certain time. So when we're going to get to the 2 kilometer mark, we're going to get there at the end of week 25. And you've got no idea of that in a bar chart. And equally, we can see the relative rate of production within a task or between tasks. And so you can see that due to a change of production, we're going slower at the beginning and then we're getting faster as we get used to this process. So they're important bits of information that it conveys, but the key one, of course, is when we plot other activities, we can see that B follows A both in start and finish, but there's a clash. There's a problem in the middle here where two processes are happening at the same time and in the same place, and that may be a problem. It may not, but generally speaking, it is something to be avoided. And in TILOS, you've got distance as a calculation component in a rescheduling type environment, and so we can find solutions to those problems in an elegant way, far more elegant than you would in traditional systems like Power Project or P6 or Microsoft Project. But also you get environmental obstructions, you get things at a certain place that you've got to work around, such as bat nesting season in a particular location. And again, because that's a distance problem, you've got an elegant solution to that in TILOS. So time distance planning as a concept, aided by the presentation and the computational abilities of TILOS, is really second to none, and that's why it's been used over many years and is the serious market leader in this area. So there are two concepts in TILOS I want to quickly talk about. One is about views. So views are familiar to Power Project users and to Microsoft Project users, and to P6 it would be most similar to layouts. And this is where we're creating a graphic on screen, and that's what we're going to print and work on screen. And we're creating a view made up of cells, and each cell has got a particular sort of data. So I create a cell, an initial cell of making a new view, and in that view, in that cell, I say initially what is the time axis. Time is vertical, so that blue stripe is a holiday period. Distance is then horizontal, so we can create a second cell on the distance axis, and we can create our own distance. Really, we can have as many rows as we want with whatever font marks, whatever frequency of tick mark for regular items. And we can have another cell, a distance cell on top of the first one, and there we can embed a graphic that shows us a picture of the project and gives people a concept in where we're locating things. And that can be an imported picture, or that could be created with the graphics within TILOS itself. We've got a time cell on the left hand side, and in there we can create our own time ruler with many columns as we want. We can have week numbers, including strange numbers that aren't annual, like network rail week numbers, not restricted to 3. And if the activities have got resources on them, then you can have a histogram with an individual resource picked out, and you can see how many are going to be used over time and color code those. You can have graphs where you're seeing a cumulative and a period amount, so you're seeing how much money or profit in total or per month, or that could be man hours of effort, or that could be cubic meters of material. And in the same way, on the distance axis, we can also have irregular objects, such as in this case drains, but that could be stations or overhead line masts on a railway. And on the distance axis, we can also have the same graph. So we can have resource and cost graphs, so you can see how much it costs per kilometer. And on the distance axis, there's a particular specialism in a diagram called a mass haul, which is where we're going to chop down small hills and fill in small valleys to make a road or a rail bed. And then you can plot how you move soil from one location to another in haulage. And around the outside of the diagram, there is a containing cell that you can make a graphic cell, and in there you can embed a legend that reference what the different activity colors and shapes mean, that we'll talk about in a moment. You can have embed a bit of Excel or create text boxes and have a title block, and you can have any number of different logos. All of that is a view. It's saved away, it's got a name. You can double click on it to recover it, and you can have a number of views. So you might want to say, well, I only want to see what's happening in October and November, and I only want to see that between 1.5 and 2.5 kilometers. So we can have a different view with or without the graphs that's just focusing in on a particular area and time. And you can filter in other ways, more traditionally by other attributes of activities. So view management is an idea that needs to be understood, and it's made up of cells, and you can create them, and they're incredibly flexible. But the other central idea is a task in TILOS is exactly the same as it is in any other classical project management system. It's got an ID and a start and end date. But what it must also have is a start and end distance. And in TILOS directly, you're doing that from implicitly how you create the activity. But if you're importing that from another system, then you also need to put the start and end distance in some user text columns or another area of that program, so we can locate it in time and distance. So a number of tasks go to make up a project, or strictly speaking, a sub-project. A sub-project in TILOS is not the same as a work breakdown structure, which is also present in TILOS, but is about a branch line or the up line of a railway and being different to the down line of a railway, or a branch line or a side road where they have a different chainage. And all of that can be seen in a view or as much as you wish. But when we create an activity in TILOS or we import it, we nominate a task template reference that's been set up before, and that task template is a prototype task that doesn't yet exist, but has got all of the attributes of that task. In particular, it's got a shape and a color. So all culverts in my diagram, I'm going to create a task template called culvert. I'm going to make it a yellow rectangle, and so I nominate that this next task is going to be a culvert. I create it in TILOS, it's a yellow box. I import it from externally, nominating it as a culvert, and it will be a yellow box. So we need to set up a task template library, and they can also hold a rate of production and also the resources and costs. So in one operation, we can create quite a complicated activity. And as you see, we can also have template groups, which are fragnets of pre-prepared processes. So you can just draw a rectangle and create a whole project plan that's been pre-prepared. And that is exactly what rail possession work does. So TILOS is a fully featured resource progress cost management system, but with distance as a key driving force.